Welcome to MRL. In this learning session, we'll be learning how to solve the exercise sets from 3.1 to 3.4. The remaining exercise, that is 3.5, and the end question chapter will be learning in the next video. Before you go to the solutions of these chapters, I expect or I believe that you have all gone through the world of numbers videos which were uploaded, and also you have understood the basics of the world of numbers chapter. If you have understood the basics, then try to understand how to solve the exercise sets of this particular chapter. Now in exercise set 3.1 we have a few examples which we'll learn to solve them now. Now in the first example, if you read the statement, there are 2 bags and the person gets 15 ingots for 2 bags. For 2 bags he gets 15 ingots. Now we have to find how many ingots he gets for 12 bags. For 2 bags we have got 15 ingots. For 1 bag it will be 15 by 2 ingots, because for 2 bags it is 15, therefore 1 bag it will be 15 by 2 ingots. For 12 bags it will be 15 by 2 into 12, that is 15 into 6, that is 90 ingots. So this method of finding out the number of ingots is called as a unitary method. In unitary method we find for one and then for many, so it's called as one to many method of solving the example. Now the second method is the ratio and proportion method. We have the bags here. The bags are 2 and ingots are 15. For bags 12, the ingots he gets or receives is x, and it's a direct variation, and therefore we can cross multiply it and get 2x is equal to 15 into 12, x is equal to 15 into 12 divided by 2, and that is 15 into 6, that is 90 ingots. Therefore the merchant receives 90 ingots for 12 bags. Remember that. Okay. Now coming to the next example, if you read the statement, a question in the textbook, you find that the number of notches on a Shango bone are 11, 13, 17 and 19. These are the notches which are marked on the Shango bone. Now we have to find out what are these numbers, or what are the type of these what are the type of numbers given 11, 13, 17 and 19, and also give the next 3 numbers. The number notches 11, 13, 17, 19 are prime numbers between 10 to 20, and that's very clear. 11 is a prime number, 13 is a prime number, 17 is a prime number, 19 is a prime number lying between 10 and 20, 10 to 20. The next 3 prime numbers are after 19 we get 23. 23 is the next prime number, 29 is the next prime number, and 31 is the next prime number. So that is what you have to remember. Now the third example, it is given that closure property of addition is closed for natural numbers. It is 100% true that closure property of addition is closed for natural numbers. Now we have to justify why the closure property of subtraction is not closed. Please understand here, we have to justify why the closure property of subtraction is not closed for natural numbers. So let us understand the justification here. We know that the set of natural numbers is n is equal to within the braces 1, 2, 3, 4, 5, 6 ... that is endless. Now let us consider 2 numbers 4 and 7 which belong to natural numbers, and if I subtract 7 from 4, 4 minus 7 is equal to minus 3. Minus 3 is not a member of natural number set, or it does not belong to n, and therefore the closure property of subtraction is not closed for a set of natural numbers. So also if you take another example 5 and 9, 5 minus 9 is minus 4. Minus 4 does not belong to n, and therefore closure property of subtraction is not closed for a set of natural numbers. So please remember that closure property of addition is closed for a set of natural numbers, but not the closure property of subtraction is not closed for a set of natural numbers. Now coming to the next example, in the statement or in the example given, the fourth example in the textbook, he says the joints of fingers of a hand are used to count with thumb as the pointer. Please understand, joints of fingers of a hand are used to count with thumb as the pointer. Each finger has 3 joints, and it is true also. Now we have to find out how many counts is possible with one hand, and that is the 4 fingers using thumb as the pointer. The number of fingers on a hand are 4. Thumb is used as a pointer. Joints on each finger, as you count them, there are 3. Each finger has 3 joints. Total counts possible are 3 joints of one finger. There are 4 fingers, so 4 into 3 is 12 counts. So therefore 12 counts is possible with one hand. Very simple it is. Now understanding as to what is base 12 system. This is the second part of the same question. Base 10 system, as you know, has 10 symbols and 10 counts starting from 0 to 9. So base 10 is a base 10 system, has got 10 symbols or 10 counts. Now similarly, by one hand the joints counted are from 1 to 12, so the count relates to base 12 system or duodecimal system. Also we know that base 2 system has 2 counts, base 5 system has 5 counts, therefore the count of 12 is a base 12 system. That is the conclusion which we can draw. Now coming to the next exercise, that is exercise set 3.2. Now if you read the statement again, that is the first example, you are given that the noon temperature in Ladakh is 4 degrees Celsius. The midnight temperature is 15 degrees less than the noon temperature. So we have to find out what is the midnight temperature. Now the noon temperature is minus 15. Noon temperature is minus 15. The noon temperature minus 15 degrees Celsius is midnight temperature. That means 4 minus 15 is equal to minus 11. Therefore the midnight temperature is minus 11 degrees Celsius. That means it's very clear the noon temperature in Ladakh is 4 degrees Celsius. It is 15 degrees less in the midnight, and therefore 15 degrees less from noon temperature is 4 minus 15, and that is minus 11. Therefore the midnight temperature is minus 11 degrees Celsius. Remember that. Now the second example is a person takes a loan of rupees 850, which is a debt, and therefore when it is a debt I can write it as minus 850. The profit made by him, that is rupees 1200, we can consider it as a fortune, and therefore it is plus 1200. Again he incurs a loss of rupees 450, which can be taken as a debt, and therefore it is minus 450. Now we have to find out the financial standing of the trader. Now the total money transaction is minus 850 plus 1200 and minus 450. That is debt plus fortune and debt again. So now we have to subtract the debts from the fortune. Therefore minus 1300 plus 1200, that is minus 100. Therefore the trader has a debt of rupees 100. So the money transaction leads that is that the trader has a debt of rupees 100. Now remember that. Now coming to the next point, to simplify using Brahmagupta's laws. If you read the textbook, that is World of Numbers, in that there are some Brahmagupta's laws given in terms of debt and fortune. So you have to apply them and solve these examples. Now let us take the first example. The first example is minus 12 into 5. Minus 12 is debt and 5 is fortune. And debt into fortune is again a debt. That means minus into plus is minus, and therefore it is minus 60. 12 5 is 60, and since it is a debt it is minus 60, or the minus into plus becomes minus, and therefore it is minus 60. Now the second example, minus 8 into minus 7. Now debt into debt is fortune, and or we can even say minus into minus is plus, and therefore it is 56. Now 0 minus of minus 14, that means it is 0 minus debt. Minus 14 is debt here, and that is fortune, and therefore it is 14. Or minus into minus is plus, or taking additive inverse and changing the minus sign to plus, we can take the additive inverse of minus 14, that is plus 14. So 0 plus 14 is 14. So there are 3 different ways of explaining this. One with the help of Brahmagupta's laws, then applying the sign rule of multiplication, and also using additive inverse, changing the subtraction to addition. We can change minus 14 to plus 14. Plus 14 is the additive inverse of minus 14, and therefore we get the answer as 14. Now minus 20 divided by 4, again debt divided by fortune is debt, or minus divided by plus is minus, and therefore you find the answer as minus 5. There is another way of putting it. Minus 20 can be written as minus 5 into 4, and divided by 4, 4 and 4 will cancel, that we get 1. Therefore it is minus 5 is the debt, 1 is the fortune, and therefore it is debt into fortune is again a debt, which we already know by Brahmagupta's laws, and therefore the answer is minus 5. Remember that. Now we are given an example here that 10 minus of minus 5 is equal to 15. To explain why subtracting, we have to explain why subtracting a negative number is the same as adding a positive number. Now the explanation is very simple here. Now subtraction is addition of additive inverse. Please understand, subtraction is addition of additive inverse of subtrahend. Now here 10 is the minuend and minus 5 is the subtrahend. Now if I take the additive inverse of minus 5, it becomes plus 5. Then I can change minus to plus. That means I can convert the subtraction to addition by taking the additive inverse of the subtrahend, and that is exactly we have done here, and we get the answer as 15. So please remember this simple what you call property. Now if to explain this with the help of an example, let us say a person has rupees 10,000 and has taken a loan of rupees 5,000. If the person's loan is cleared, okay, whether he clears it or someone clears it, his debt is cleared. If the debt is cleared, the person becomes richer by rupees 5,000, which gets added to rupees 10,000, and therefore the total amount becomes 15,000. So this is exactly how the Brahmagupta's what you call laws explain it, and here we have explained with the modern property, that is minus 5. Additive inverse of minus 5 is plus 5, and subtraction becomes addition. So please remember, subtraction is nothing but addition when we take the additive inverse of the subtrahend. So that is what is the property applied here, and we get the answer as 15. So please remember that. Now let us go to the next exercise, that is exercise set, that is 3.3. Now here we have to prove that the following rational numbers are equal. So very simple. Now we have been given a rational number 2 by 3 and 4 by 6. Now to prove that they are equal, just check their cross products. If the cross product of 6 into 2 is 12 and 4 into 3 is 12, the cross products are equal, that means the two rational numbers are equal, and that is exactly what I have shown here. Similarly, 5 by 4 and 10 by 8, 5 into 8 is 40, 10 into 4 is 40, cross products are equal, therefore the two rational numbers are equal. And here minus 3 by 5 and minus 6 by 10, if you take minus 3 into 10 is minus 30, and minus 6 into 5 is minus 30, cross products are equal, and therefore the two rational numbers are equal. 9 by 3 and 3 by 1, 9 into 1 is 9, 3 into 3 is 9, cross products are equal, and therefore 9 by 3 and 3 are what? Equal rational numbers. A very simple method. So please remember the basic, if the cross products of rational numbers are equal, then the rational numbers are equal. Now coming to the next, that is the second question, to find the sum of rational numbers. That means please understand here the property, that is operations of rational numbers. Addition of rational numbers is always a rational number, whether it is addition, subtraction, multiplication or division of rational numbers, it is always a rational number. Here the sum of two rational number is again a rational number. So let us see how to do that. Now we are given rational number 2 by 3 and 3 by 10. We have to add them. To add them, if you see here the denominators are different, find the LCM of denominators, it is 10, and make the denominators as 10 by multiplying by 2 here, that is 2 into 2 is 4, 5 into 2 is 10, 3 into 1, 10 into 1, so we have made the denominators same. When the denominators are same, then we have to add the numerators, so 4 plus 3 is 7, 7 by 10 is the what you call sum of these two rational numbers, and again it's a rational number. So sum of two rational numbers is again a rational number, and that is a very important property. Now addition of 7 by 12 and 5 by 8. Now if you observe here 12 and 8 are different. Find the LCM 24. If the LCM is 24, then 12 to the 24, 7 to the 14, 8 is the 24, 5 3 is the 15. Add 14 and 15, we get 29 by 24, which is again a rational number. Now take minus 4 by 7 and 3 by 14. You find the LCM of 7 and 14 is 14. So 7 to the 14, 4 to the 8. Then 14 1 the 14, 3 1 the 3, minus 4 into 2 is minus 8, 3 into 1 is 3, add, you get minus 5 by 14. So that is how we add the rational numbers, and we find that the sum of rational numbers is again a rational number. Now the third one is here, we have to find the difference of rational numbers, as again I have told you subtraction of rational numbers is again a rational number. Let us understand this. Now we are given a rational number 5 by 6 and a rational number 1 by 4. Now we have to subtract it. The denominators are different, make the denominators same. So LCM is 12. So if I take the LCM as 12, then 6 to the 12, 5 to the 10, 4 3 the 12, and 3 1 the 3. So please remember that. So 10 minus 3 is 7 by 12. So that is the subtraction of two rational numbers here. Now similarly here, 11 by 8 minus 3 by 4. LCM is 8. Taking LCM as 8, 8 1 the 8. 11 on the 11, 4 to the 8, 3 to the 6, 11 minus 6 is 5 by 8, and that is again a rational number. Minus 7 by 9, minus of minus 2 by 3, minus of minus becomes plus, so minus 7 by plus 2 by 3, LCM is 9, and if I take it as 9, then 9 ones are 9, minus 7 ones are 7, 3 3s are 9, 2 3s are 6, minus 7 plus 6 is minus 1 by 9, and it's again a rational number. So that means subtraction of two rational numbers is again a rational number. Now coming to the product of rational numbers, again the product of two rational numbers is again a rational number. So let us consider example here. 2 by 3 into 3 by 10, that multiply the numerator, multiply the numerator and the denominator, multiply the p's and q's, you will get 2 into 3 is 6, 3 into 10 is 30. Again the HCF of 6 and 30 is 6, divided by 6 we get 6 divided by 6 is 1, 6 divided by 30 divided by 6 is 5, the answer is 1 by 5. Or else you can directly cancel, 3 and 3 will cancel, 2 ones are 2, 2 5 are 10, 1 by 5 you will get. So that is the direct method. Now come to the next example. 7 by 11 into 5 by 8. 7 by 11 into 5 by 8 is 7 5 is 7 into 5, and 11 into 8, 7 5 is 35, 11 into 8 is 88, and there is no HCF possible here, and therefore the answer is 35 by 88. Now take the next example, minus 4 by 7 into 5 by 14. Now find out what you call the multiply. Minus 4 into 5 is 20, 7 into 14 is 98. Now find the HCF. The HCF is 2, divided by 2 will get minus 7 by 49, or else you can directly cancel. Okay, this goes by 2, and that also is possible. Now the next example, or that's what I have written here. Minus 4 by 7 into 5 by 14 is 2 to the 4, 2 7s are 14, then 5 to the 10, and 7 7s are 49, minus 10 by 49. So therefore this is the direct method. This is how we do it, by taking the HCF. But one thing is very clear, that product of two rational numbers is again a rational number. Now coming to the next one, that is to find the quotient. That means division of rational numbers is again rational number. Now 2 by 3 divided by 3 by 10 are the two rational numbers given. So division means convert into multiplication. When I take it convert into multiplication, I have to take the reciprocal of 3 by 10, that is 10 by 3. Please remember, when division is converted into multiplication, we can take the reciprocal. So 10 by 3. So now you have 2 into 10 is 20, 3 into 3 is 9. If you want, you can keep it as 20 by 9, or write it as a mixed fraction, that is 2 integer 2 by 9. Now coming to the second one, 7 by 11 divided by 5 by 8. 7 divided by 11 into 8 by 5, because I have taken the reciprocal here again, so it will be 56 divided by 55. 7 8 is 56, 11 5 is 55. Now come to the next one, minus 4 by 7 divided by 5 by 14. Now if you want to cancel directly, 2 to the 4, see, you can take the reciprocal, 7 on the 7, 7 to the 14, and we have minus 4 into 2, 1 into 5, that is minus 8 into 8 divided by 5. So in as far as the division of rational numbers is concerned, you have to take the reciprocal of the what you call the multiplier. You can take the reciprocal of the one, that is the divisor. You can take the reciprocal and then go ahead with the calculations and get the product and get the answer. Now the next example, that is we have to show that 1 by 2 plus 3 by 4 into 8 by 3 is equal to half into 8 by 3 plus 3 by 4 into 8 by 3. This is nothing but distributive property, that is distribution property of multiplication over addition. So please understand this. So let us see, we have to prove that LHS is equal to RHS. So let us go for the proof. Take LHS first, that is half plus 3 by 4 into 8 by 3. Now add the, always you have to apply BODMAS here, add the rational numbers in the bracket first. So when we add, the LCM is 4, 2 to the 4, then 4 on the 4, that is 2 into 1 is 2, 3 on the 3, 2 plus 3 is 5, 5 by 4, and then multiply by 8 by 3. 4 on the 4, 4 to the 8, you get 10 by 3. Now that is LHS value, you have got 10 by 3. Take RHS. Now 1 by 2 into 8 by 3. 2 on the 2, 2 4 are 8, you get 4 by 3, and 3 by 4 into 8 by 3 becomes 4 to the 8, that is 6 by 3. Now the denominator same, 3, so take 3, then add 4 plus 6, 10 by 3. You find that LHS is equal to RHS, the values are same, and therefore that proves the distributive property is closed for a set of rational numbers. Remember that the distributive property is closed for a set of rational numbers. Now coming to the next example, that is example number 7, you have to simplify using distributive property. Now what is distributive property here? A in the bracket B minus C is equal to A into B minus A into C. We have to use this property and prove it. Now we are being given 7 by 9 in the bracket 6 by 7 minus 3 by 4. So multiply this A with B, that is 7 by 9 into 6 by 7, then minus sign 7 by 9 into 3 by 4. Now simplify these two. That means we have got 3 3 is 9, 3 2 is 6, 7 7 will cancel. We have got 2 divided by 3, and we have got here 7 divided by 12. Now denominators are different, make the denominator same. The LCM is 12, and 3 4s are 12, 4 2s are 8, 12 1s are 12, 7, so 12 1s are 12, 7 1s are 7, 8 minus 7 is 1, 1 by 12. So the answer is 1 by 12. So therefore remember, then this is also a distributive property, but here it is not addition but subtraction. Now to find x, now you are being given example 5 by 6 in the bracket x plus 3 by 5 is equal to 5 by 6 x plus half. We have to find the value of x. Let us simplify the LHS first. 5 by 6 into x plus 5 by 6 into 3 by 5 is equal to 5 by 6 plus half. Now if I simplify this, I get half, that is 5 by 6 x plus half, 5 by 6 x plus half. So if you observe this, if you inspect this, you find that LHS and RHS are both equal. So 5 by 6x and 5 by 6x are also equal, half is also equal to half. So by inspection we find that x can take any rational number, and that is the value of x. So x can take any rational number here. Put any rational number to x, LHS will be equal to RHS. So that is what is the answer for that. Now coming to the next exercise set, that is exercise set number 3.4. Now let us understand here. Now we are given 2 by 3, minus 5 by 4 and 1.5. These are three rational numbers. Now we have to represent these rational numbers on a single number line, one number line when you represent all the three. Now 2 by 3, if you observe very clearly, lies between 0 and 1, because 2 by 3 is less than 1, so it lies between 0 and 1. Minus 5 by 4 lies between minus 1 and minus 2, because minus 5 means we will get more than 1, so it is minus 1 and minus 2. 1.5 lies between 1 and 2. So draw a number line. Draw a number line and mark 0, 1 and 2 on the right side, minus 1 and minus 2 on the left side. Now let us locate 2 by 3. When I say 2 by 3, from 0 to 1 I have to make 3 parts. 1 part, second part, third part. So this is 1 by 3, this is 2 by 3, so 2 by 3. So the point A on the number line represents 2 by 3. Now coming to 1.5. 1.5 is, see, please understand, between 1 and 2, it has to be divided into 2 parts. So this is 1 part, this is second part. So this is 1 and this is half. So it is 1.5, or that is the point, that is 3 by 2, and that is the point B. So point B represents 1.5 here. Now coming to the minus 5 by 4. Now we have got 0 and minus 1, and I want minus 5 by 4. I have to divide minus 1 to minus 2 into 4 parts. So this will be minus 5 by 4 parts. So this is minus 5 by 4. This is minus 4 by 4. This is minus 1. This is minus 5 by 4. So the point C represents what you call minus 5 by 4 on the number line. Therefore, the number line, the point on the number line, the points A, B and C represent the given rational numbers. So please remember that it's a very simple construction, simple representation. So try to learn and understand. Now we are given the second example. We are given minus half and 1 by 4. We have to find three rational numbers that lie between minus half and 1 by 4. We have to find three rational numbers between minus half and 1 by 4. So there are different methods of finding out these rational numbers. Now first method is the average method. Now what is this average method? Let us say you have got a number A, that is rational number A, rational number B. Add these two rational numbers and divide by 2. We get the middle number, or the number between A and B. So the same method I am going to apply here. So let us start. Now let us take minus half, that is A, and take B, that is 1 by 4. So A plus B divided by 2 will be minus half plus 1 by 4 divided by 2. Simplify this now. Now if you see 4 and 2, LCM is 4. So 2 to the 4 and 4 on the 4, therefore 2 on the 2, that is minus 2 and plus 1, and therefore minus 2 plus 1 is minus 1. 4 will come down here, 4 into 2 is 8, therefore minus 1 by 8 is the number. So we have got the middle number between, we have got the center number or middle number between A and B. Now we want another number that is between A and C. A is minus half, C is 1 by 8. Add these 2 divided by 2. So minus half plus minus 1 by 8 divided by 2. Again 2 and 8, okay. Please understand here, 2 and 8 minus half and minus 1 by 8 divided by 2, and that will be, if you observe here, 8 is the LCM. So 2 4s are 8, that means 2 4s are 8, 8 1s are 8, minus 4 minus 1. If you simplify, 8 into 2 is 16, minus 5 by 16 you will get, and therefore the number between A and C is minus 5 by 16. That is another rational number we have got. Now we want one more, so I will take C and B. So add B and C. Add B, that is 1 by 4, and C, that is minus 1 by 8. So I have added minus 1 by 8 plus 1 by 4 divided by 2. By simplification, I got 1 by 16. So we have got the third rational number. So therefore, minus 5 by 16, 1 minus 1 by 8 and 1 by 16 are the three required rational numbers between minus half and 1 by 4, and this is what is called as the average method of finding the rational numbers between given rational numbers. So please remember this. Now we have got another method that is called as the denominator method. So we have been given minus half and 3 by 4 as the what you call the two rational numbers. Minus half and 1 by 4 are the two rational numbers, not 3, it is 1 by 4. So three rational numbers we have to find out. So what we do is we will adopt a different method now, not the average method. This is called the denominator method. So let us understand this. I have explained very clearly here. So let us take minus half and 1 by 4, minus half and 1 by 4. If you find that 2 and 4 are denominators which are different, so first step is make the denominator same. So what I will do is I will multiply by 2 and divide by 2. Minus 1 into 2, 2 into 2 becomes minus 2 by 4. 1 by 4 remains as it is, and therefore I have made the denominator same here, 4 and 4. Between minus 2 by 4 and 1 by 4, we will not get the required three rational numbers. To get the required three rational numbers, we have to multiply by some constant which gives us the three rational numbers. So I have multiplied here by 2. So minus 2 into 2, 4 into 2, 1 into 2, 4 into 2. So it will be minus 2 into 2 is minus 4, 4 into 2 is 8, and therefore minus 4 by 8 and 2 by 8. So between minus 4 by 8 and 2 by 8, we have got we get three rational numbers of less than minus 4, greater than minus 4 is minus 3 by 8. Greater than that is minus 2 by 8, and greater than that is 1 by 8, which is less than 2 by 8, and therefore minus 3 by 8, minus 2 by 8 and 1 by 8 are the three rational numbers which lie between minus 1 and 1 by 2 and 1 by 4. So this is what is the denominator method of finding out the required number of rational numbers between any two given rational numbers. So please remember that. Now the third example is we have to simplify this expression. The expression given is minus 1 by 4 and 5 by 12 plus 5 by 12. So let us see how to do this. Minus 1 by 4 plus 5 by 12, and 4 and 12 LCM is 12. So make the LCM, that means the denominator is 12. So I multiply this by 3 and 3. So it will be minus 1 into 3, 4 into 3, minus 3 by 12, and here it is 5 by 12 only. Now LCM is 12. So the denominators are same. So add the numerators, that is minus 3 plus 5, that is plus 2 by 12, that is plus 1 by 6. A very easy example. So try to learn and understand. Now coming to the next and very important example given in your textbook, that is there is a tailor. He has a silk cloth with him, and the cloth is 15 3 by 4 meters. The silk cloth is how much? 15 3 by 4 meters. Now he wants to stitch kurtas, and the cloth for one kurta is 2 integer 1 by 4 meters. So he has this much cloth, and for one kurta he has to use this much. Now we have to find out how many kurtas he can stitch. So the number of kurtas which he can stitch are the total silk cloth he is having divided by the cloth of one kurta. So that means 15 integer 3 by 4 divided by 2 integer 1 by 4, and that is 63. By taking the converting mixed into improper, that is 63 by 4 divided by 9 by 4, and division becomes taken by multiplying, take the reciprocal. So we have got 63 by 4 into 4 by 9, and 9 into 9, so the 63 4 will cancel, we get 7. So therefore the tailor can stitch 7 kurtas from the cloth he is having. So that is a very simple example, so try to remember that. Now we are given here two numbers, 3.1415, 3.1416. These are decimal expansions, terminating decimal expansions. Definitely they represent rational numbers. Now we have to find out three rational numbers between these two. Now for that, a simple method I am going to adopt. First of all, I will add 0 to both the because there are 4 digits here, I will make them 5 digits. So by adding 0 to both, I added 0 and I made it into 5 digits. Now 3.14150, between 3 and 3.14160, there are many decimal numbers which lie between them. We have got 3.14155, 3.14156, 3.14158, and that means between these two numbers I have three decimal numbers which have decimal expansions which I have written here, and these three decimal expansions 100% represent the rational numbers because they are terminating decimal expansions, and terminating decimal expansions definitely represent rational numbers, and that is how we have found out the required three decimal expansions which represent rational numbers between the given two decimal expansions. A very simple example, try to remember that. Now coming to the sixth example, that is methods of finding rational numbers between any two rational numbers. Very interesting. Now we have already learned this, that is we know that there is an average method of finding the rational numbers between two rational numbers. We have got the denominator method which we already learned by example. Now there is another method called as the decimals method. Now let us say for example we want to find three rational numbers between 2 and 3. First of all, write the decimals between 2 and 3. We have got 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and 3. So between 2 and 3 we have got these decimal numbers. Now convert this to, now we want three rational numbers. So convert 2.2 as a p in the p by q form. 2 by 2 becomes 22 by 10. 2.4 becomes 24 by 10 and 2.7 becomes 27 by 10. We have been asked three rational numbers, that's why I have converted them into p by q form, and these three are 100% rational numbers between the given two numbers 2 and 3. So this is what is called as the decimals method. So therefore to find out the required number of rational numbers between two given rational numbers, we have got the average method, we have got the denominator method, we have got the decimals method, and any one of these methods can be adopted to find out the required number of rational numbers between any two given rational numbers. I think the denominator method is much easier, and also of course the decimals method is also easier, but denominator method is preferred for many reasons which you will understand when you solve examples, many examples related to them. Okay, so remember this much. This is what I have discussed up to exercise 3.4. In the next video we'll be learning about exercise 3.5 and the end chapter questions. But what I suggest is please go through the textbook, learn every basic, all the basics, go through my videos of all the basics which I have given you. There are 6 videos uploaded. Please go through all of them, then attempt these questions, otherwise you will not understand how to solve. So learning the basics is very important before you attempt the questions, or before you start solving the examples. Okay, then learn them. Okay, be good in what you call world of numbers. It's your world and world of numbers. Okay, thank you.